Hello and welcome to Algebra 2A, Credit 5. Today we'll be going over radical functions, expressions, and equations. Let's begin with a brief overview of what you'll be seeing in this credit. For Module 10, which is Chapter 10 in your textbook, we'll be going over radical functions. You'll see on your first page there's a due date and a completion date. Start placing your own goals of what you'd like to finish by when. Setting a goal for yourself is very important, so that way you can kind of see how long it actually takes you to get through each section. So 10.1, 10.2, 10.1 inverse of simple quadratic and cubic functions, and 10.2 will be graphing square root functions. You'll also see listed above, before I continue, textbook pages as well as assigned problems that you'll see from your textbook. This will be your homework, and remember that does count towards your grade. And that appears for every single chapter. You'll also see that there were literally only 2 sections for Module 10, and for Module 11 you'll see that there's 11.1, 11.2, as well as homework assignments, and 11.3. After which you are done with that credit, so to speak, for your homework and classwork. You will then start on the credit checkpoint and be prepared to take the quiz. We'll be doing about 1 a week, 1 credit per week, so we'll spend majority of today's videos going over each of these sections and giving you time in class to do homework, as well as on our next visit, our next class will be going over credit checkpoint and having you take the quiz. So let's jump right in where it says Algebra 2A, Credit 5. Radical functions and expressions and equations. There's a couple of things we wanted to have you do before you kind of dive into this credit, just as a warm-up, reviewing exponents. So one of the first ones you see here, you'll see there is an example, and then there are about a few problems for you to do. So I'm going to do an example that's unlike the problems that you see here. So here you have x to the third times negative 4x to the fourth. Before I begin in solving this out, I just want to say that there is a coefficient here, though there doesn't seem to be. There is a 1 there, because there's 1 x to the third power, just like there's 4 negative x to the fourth powers here. What you're going to do to simplify is multiply your coefficients. And your coefficients are going to be these numbers to the left of your variables. So 1 times negative 4. You will also, if the variables are the same, which here we have a x variable and an x variable, we will add exponents of like variables. Now notice I didn't say like terms because they're not like terms, but like variables. So that would be x to the third power plus to the fourth power. So here if I simplify each, because this is not the appropriate answer, that would be negative 4 x to the 7th power. Try out number 1 and number 2. You can always check with your teacher or tutor to kind of check that out and see if that's correct, but go ahead and try that out. The next thing we're going to do is simplify. So this is another example. It may not be in your packet, but it'll help us with number 3. So here you see 5y to the third times 4x squared y minus x to the third power. What I'm going to do is distribute the outside term outside the parentheses to what is inside. And distribute just means to multiply what is outside to what's inside. And inside what? Inside the parentheses. So here that would be 5y to the third power times 4x squared y. And that would again be 5y to the third power times negative x to the third. I'm going to write a little symbol in between. I know you're like, there wasn't a negative there. in between those two, but just for the sake so that I know that this is one problem. And think of that plus sign as like an and this is another problem I have to simplify. I'll leave that there for now. So let's go ahead and simplify each of these problems and see what we get. So here that would be, again, we're going to follow the same rules. We're going to multiply our coefficients. So that's 5 times 4. Here I have a y and a y, so I'm going to write y 3 plus 1. Now a lot of students are like, there's not a 1 there. Well, there is a 1 because there's one y. So that's a 3 plus 1. Now x to the second power, I don't see any x's here. So I'm going to just leave that as x to the second power. I like to write them in alphabetical order, so x comes first and then y. It just helps out. And then I'll simplify that even further. 5 times 4, x squared, and y. 3 plus 1 would be 4. Moving on, I have 5y to the third power times negative x to the third power. Now, how many negatives are right here? 1, right? So I'm going to multiply 5 times negative 1. I don't see any like variables at all, so I'll write my x term first, my y term second. Again, keeping in alphabetical order, x and then y. I'll go ahead and multiply these two together. 5 times negative 1, which is a negative 5, and x to the third power and y to the third power. And that would be our solution. What you could do if you'd like, you could write it like this, because I know a couple students will say, hey, what about that plus symbol you put in the middle? Okay. You could also write it like this if you'd like. Either one's okay. Alright. So either one's fine. This one's just more simplified because, you know, it's like me saying 20x squared y to the fourth and negative 5x to the third y to the third. You can say it, you know, there's 20x squared y to the fourth minus or negative 5x to the third y to the third. Whichever. This one you'll probably see more prevalent. Alright, try out number 3, but we'll continue on with the next review, which is inverse linear functions. So this is going to be a great review, especially for our first lesson of writing the inverse of y equals x plus 9. So here's our example, and then you can try out number 4 and 7. So the first thing we're going to do is just solve for x. So I'm going to draw a line straight down the equal sign. And x is what I want to get by itself. And I need to get rid of whatever is being added to, multiplied, subtracted, or divided to x. So first thing I'm going to do is get rid of, well, there's a 9 being added. So we're going to do the opposite. What is the opposite of adding 9? Subtracting 9, right? So we'll subtract 9 to both sides. 9 take away 9 is just 0. Kind of cancels out. I have left over x. Now, since y and 9 are not the same, I mean, that's a variable, that's a number, I'm going to write y first and then negative 9. So on here, as you can see, I kind of wrote down the steps for each one of these. So we solve for x, we simplified. The next thing we're going to do is now switch the x and y variables. So here I had an x here and a y there. So I'm just going to switch places and put the x here and the y there. And that would be the inverse. Okay. Alright, so there you go. Yeah, let's go ahead and try out number 4 and number 7. Alright. Another example that we can do that's not in your packet, but that will help you with number 5 and 8 in these exercises is how we find the inverse of something like y equals negative 4x. So the first thing we're going to do is we are going to solve for x. So I'm going to draw my line straight down the middle, and I'm going to try and get rid of whatever's being added, subtracted, or multiplied to x. And in this case, there's a -4 being multiplied to x. And what's the opposite of multiplying? That's 1L. And that would be dividing. So I'm going to divide both sides by -4. Just so you know, whatever that is that's next to x, we do want to still divide by that same number. So if that was a 5 or a 10 or -2, we would still divide by that same exact number. What that's going to do is -4 divided by -4 is just a giant 1. So now I have 1x. If you want to write that 1 there, you can, but you don't really need to. It's 1x. Alright, so now that we've gotten this far, we have solved for x, we have simplified. Now what we're going to do is we are going to switch the variable. So instead of x being on this side and y being on that side, we're going to switch places here. So that's x over -4, x divided by -4 I should say, equals y. And that would be the inverse of our original equation. Go ahead and use that example to try this out for 5 and 8. Alright, so for number 6, which is a little different, I'm just going to do one more example so you can kind of see how that's done. Again, I'll draw a line straight down the middle and we'll solve for x. So you'll see that I'm multiplying by 1 over 4. So what I'll do is I'll multiply by the reciprocal of 1 over 4, which would be 4 over 1. Alright, what that's going to do is that's going to cancel out these fractions, and I'm left with x equals, well, 4 divided by 1 is just 4, so my would be 4y equals x. So I solve for x, simplified. Now we're going to switch those variables around. So that's 4x equals y. Go ahead and use that one to help you solve for number 6. Alright, moving right along, we're going to continue with exponents and simplify each expression. So here I have -y to the third, parentheses, to the 4th power. And I can do this in multiple of ways. I have a -y to the 3rd power, which I can write now 4 times. So I can do this, which is totally fine. And the reason I wrote it down 4 times is because there's a 4 on that exponent. So if it was 5, I'd write what's inside 5 times, or if it was 6, 6 times. You get the idea. What I'm going to do, just like I did in the last ones, I'm going to multiply my coefficients, which I know you're saying, well, there's no numbers there. Yes, there are. There's one negative there, and one negative there, and another negative, and another negative. So that would be -1 times -1 times -1 times -1. And then we would add the exponents of like variables. Not like terms, but like variables. And here I have y, 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 and y, and they're all y to the 3rd. So I'm going to add all these exponents together. So I'll multiply this out. -1 times -1 times -1 times -1, which would be +1, and that would be y, 3 plus 3 plus 3 plus 3, y to the 12th. Alright, go ahead and use that to solve out for number 1. And here's another one to help you out with number 2. So here I have y to the 2y to the 3rd, parentheses, to the 2nd power, plus y to the 3rd times y to the 5th. So I'm going to treat these as 2 separate problems, and then simplify at the end. So here I have 2y to the 3rd that I'm going to write 2 times. Here I have my 2's that I'll multiply together, and my y to the 3rd plus y to the 3rd. 2 times 2 would be 4, and y 3 to the 3 plus 3 would be 6. The next thing we're going to do is simplify this side, so that would be y 3 plus 5. And that would be y to the 8th. I'm going to write that plus symbol that was there at the beginning. So that would be my simplified expression. Go ahead and try out number 2. We'll try one more out here so you can do number 3. So again, that's 4y parentheses 2y to the second power. So I'll write that 4y times 2y. I'm going to write that not once but twice. Alright, so let's multiply out our coefficients. 4 times 2 times 2 and y times y times y. So that would be 16, and y is 1, 2, 3 to the third power. Go ahead and try out number 3. We'll be continuing on with rational and radical exponents on the next video.